Okay, good afternoon, anyone else that has joined us. This is the Decommissioning webinar. Here we have Lorraine McDermott, Mark Bankhead, and myself, Lindsay Rome. On the line, we also have Rick Short from NDA. With him there is Paul Mort and Andrew Cooney from Sellaford Limited. We also have Penny Berthel from Magnox and Christina Alexander from EDF, who will be doing technical presentations for us today. So I'll hand you over to Rick, who will give you an introduction of what the webinar is for and about the PhD Bursary call.
Okay, thanks very much for that, Lindsay. As Lindsay said, my name's Rick Short, and I'm the research manager at the NDA, and I'm also the strategic authority for the University Interactions portfolio, hence my involvement in this. What we're going to do today is have a webinar about the decommissioning theme of the 2016 PhD Bursary call. As you can see from the slide, we've had webinars for all of the other themes of the call. They've taken place over the last 2 weeks. And the information from those webinars and recordings of the webinars eventually will be made available on the NNL website. So if you're interested in any of those other areas as well as this one, you will be able to go back and watch recordings of the discussions and the presentations and look at the slides from those presentations at a later date. So if we go on to the next slide, please. So just to give you a little bit of background as to why we're doing these webinars, ultimately our aim from them is to get better alignment of the PhD proposals that are coming in with the needs of the site license companies in terms of their technical and research and development needs. We're hoping that by doing these webinars, it's going to give the industry technical experts an opportunity to put forward their requirements and the areas where they've got research needs and need technical development. And it also gives the academics who are listening the opportunity to ask some questions. If they've got any specific questions or general questions about the area, they can ask those questions during the webinars and we'll answer them at the end of the presentations. So we move on to the next slide. So the way that the presentations are going to work, we're going to have about half an hour of presentations in total. The technical leads are going to give you some presentations and put forward their needs, and that will leave about half an hour at the end of the presentations for questions as well. At any time during the presentations, if you think of questions, you can click on the grey speech bubble icon on the right-hand side of your screen and type in a question using the text input functionality there. And we'll save up all of those questions and we'll answer them at the end of the presentations. Please bear in mind when you're thinking of your questions and posing them via the text forum that this is an open forum, it's a public forum, and please respect the decisions of the technical leads as to which questions they answer and how they answer them. If there's anything we can't answer in these sessions, then we'll try and address that individually after the presentation. Okay, I think that's all I had to say, so I'll hand you back to Lindsay.
Thank you very much, Rick. So we have given our technical presentation today, Penny Berthel, Christina Alexander, Paul Mort and Andrew Cooney. I'll hand you over first to Penny, who will start the presentation off. Are you on the line, Penny? Can you check?
Penny, just in case, you have to press *4 to unmute your phone.
Rick, it's Tina here. Do you want me to cover it if Penny's having difficulties?
Yes, please, Tina, if you can do, that'd be great. Right. If Penny can join us, then you'll be able to hand back over. Thank you.
Okay, I'm looking at the slide entitled NWDRF Decommissioning Working Group.
Yep.
Basically, this slide is just to try and explain what the aims are of the Decommissioning Working Group within the Nuclear Waste Decommissioning Research Forum. One of our main aims is to try and promote cross-SLC and internuclear organisation sharing and learning. It's a networking sharing forum. But what we're actually trying to do, one of our main aims is to try and identify common issues and gaps and opportunities that we all have within the industry and try and work out how we can better facilitate some collaboration and sponsorship to actually close those gaps. And as you can see from that slide, we are represented by NDA SLCs, Magnox, DSRL, LLWR, etc., Sellafield, but we also include non-NDA estates, myself here, EDF Energy, EWE, and we have Cullen, etc., that come along, the GDS, that's the Government Decontam Service, that are all involved in our working group. So what we are decommissioning is a very wide topic, so what we've tried to do here is talk to everybody within our group and come up with some themes that we think could help the most with research. Okay, if you want to go on to the next slide just to introduce the themes.
Okay.
So we've kind of got it down to 4 themes, which you're going to have some discussion on during this presentation. Characterisation and analysis. Although there is a working group that deals with characterisation, what we're trying to look at here is, you know, what and where, and characterisation in maybe more difficult areas. So where you can actually send something off-site to a lab to be characterised, how could we best do that on-site? Waste treatment methods, again, this is one looking at how could we decontam things, how could we look at the best way to treat the waste which gets it to a final disposal that gets the best use of resource. And decontamination, this is a big issue. It also has the issue of whether to decontam or not, what end products you end up with, how do we minimise creating secondary waste that we then can't get rid of, so issues around that. And then robotics and autonomous systems. This is a big area going forward, and you'll get a lot of information on this from Paul, who's going to discuss this. But there are major areas around all of the sites that we wouldn't be able to get into originally. So we need to think about how we can best use robotics to make our life easier and to make decommissioning to support the other three themes. How can we use robotics as a tool? But Paul will talk more on that. Now, I don't know if Penny joined us yet. No. If I carry on to the slide on problem statement.
Yep, we're there.
If you look at this slide is really just to give you an idea of the kind of plant that we deal with, or the kind of areas within a site that we have to deal with. There is lots of different complex plant architecture, different materials, different ways that make it hard to visualize how we can do this, and we can't necessarily just use manual work because of the challenges we have of the safety of the environment, the radiological issues. So we need to think about how can we dismantle and or deconstruct these plants, how can we best deal with the waste that comes out of it, and how can we get it to a position where we are able to decommission these areas. So if you go to the next slide, which is our solution wish list, and here we have basically just what we would really like solutions to look like. They need to be easy to use. You need to be able to do the whole life cycle of them, be easy to build, to deploy, to maintain, and to decontaminate, because you're going to have to then find a way of disposing of whatever tool you've used. There's got to be an easy way to deploy it. It's got to be able to function within the environment that you're putting it in. We've had issues in the past where we've had probes that have been put in and they've stopped working because of cabling that linked to them that couldn't cope with the environment it was in. It needs to be able to be tolerant to the environment. It needs to be reliable. One of the biggest issues that we have across all the sites is reliability of kit. So we need to be sure that it's reliable, especially if it's going to be difficult to retrieve if you have a breakdown. Cost effectiveness. It is all about, decommissioning is all about doing things smarter, quicker, cheaper. It needs to be cost effective to be able to use it. That links into the low cost solutions as well. You know, we have to be able to justify spend. It has to be the smart way of doing things, but it cannot be that it's extremely expensive. Now, the other one is visualization of invisible plant areas. So it's trying.
Hello? Yes.
Lindsay?
Hi, yeah, I think we've lost Tina.
Really?
Have you? Oh, hi. Sorry, Tina. We stopped hearing you at visualization.
Oh, right. Sorry. Well, I mean, literally, I'm always finished on that slide, because the final bits after visualization are just talking about going back to the picture of how can we do it within the space that we have in congested areas, difficult to get into. So really, I don't want to do much more than that. I want to kind of now hand over to Paul on robotics. So.
Okay, I'm ready. Shall I take over?
Do I just do star 4 to remute myself?
Yes, thanks, Tina.
So.
Okay.
Okay, I'll start off. Paul Mort, Robotics and Autonomous Systems at Sellafield site. The next couple of slides you'll see is really just trying to set the scene of what on earth robotics and autonomous systems are. My academic friends say it's a very brave person who attempts to try and define it, but I can happily write one for Sellafield. It might not be quite in line with everybody else's, but it gives you an idea of what we're talking about. And simply put, robotics and how we envisage robotics is it's more the body of the system, which would include sensors, tools, and deployment systems with limited automatic behaviour. And on the autonomous side, we're looking at more the brain, the thinking side, the self-learning part of the system. So if you just click across to the next slide, please. So we're looking here more at how we deal with the environment and learn from the environment and achieve our tasks. But we won't be setting it as a task, we will set it as goals. And this is certainly an emerging technology that's coming out more and more from the development of IT systems as we speak today. Okay, if you click next slide, please. Next slide, please. Oh, sorry, that's left one, actually. Can you go back to... So, stay there. what we're aiming for in this area of technology is we're looking to make sure that the technology that we develop is robust and is capable of operating on the site. And we wanted to use the technology in such a way that it enables a safer environment for the operative, it's safer for the facilities it operates within and the environment, and also reduces our hazard quicker and cheaper. That's the nub of where we are coming from today. Okay, next slide, please. So what does that mean? When we look at previous experience across robotic development type programs, we want to be able to have predictable costs and timescales. So we really need, as the technology matures, it to be tried and tested. We want it to improve our existing capabilities. So can we integrate it into what we've already got on site? And looking slightly further forward into the future, can we generate a paradigm shift in the way we actually carry out the business? And that's some of the focus of my presentation today. And as mentioned earlier, robotics and autonomous systems, certainly robotics, tends to deal with the harsh environment where humans can't go. But can we actually make it in such a way that maybe it'll aid an operative in his task? So it actually makes them more efficient or allows them to carry more weight or such things like that. So really try and make it the first choice rather than the second or third choice. Next slide, please. Okay, just to give you an understanding of where we're coming from a site. We are regularly learning from our past experience, and we're looking at our lifetime plan in terms of taking the site to bits and trying to drive out any risk in there, and we're trying to drive and understand our needs. That's our everyday business. But today I really want to focus on actually generating opportunities by looking at how we would interpret the future and get the right technology in order to deliver that new future. Next slide, please. This is a very simple slide. I've got very high-level type challenges, which has already been described. And there's typical challenges like understanding what the facility holds for us in terms of a challenge, so characterising the facility. Cleaning this facility up before we carry out decommissioning. That's the POCO. POCO stands for POCO. The two areas I want to focus on is that we still take these facilities to bits by putting an operative in an environment with different types of tools to take them to bits. And then there's the fully remote type operations where a human cannot actually enter into that environment. So the two green ones you see on the slide are what I'm going to focus on in the next couple of slides. Next slide, please. So here's the first challenge. At the moment, we put an operative in a protective piece of kit, and we give them a set. This is probably going to be the main process by which we remove plant and equipment. And it poses some challenges to us. One, it's the operator safety, because we actually put them in the environment. We have limited tools that are available. The challenge sometimes is that because of the nature of the environment, it does actually reduce the work time, actually operatives actually at the work face. There is secondary waste generation from the equipment he's used, from his suits, from his tools, and other equipment he needs to dismantle the plant. And he would have to cut the pieces of plant up so he can manhandle them into the respective waste streams. So those are some of the challenges posed by a man or an operative going into cell. And on the remote side, we've never come across very many remote tasks that are cheap. They are exceptionally high cost. They take a long time from conception to deployment. They are slow in compared to man entry, and highly planned, high training of capability in order to drive them. They tend to be bespoke. Even if we're using off-the-shelf equipment, we still need to put a lot of engineering and technical know-how to make them work within these environments. And the environment is not structured. It is highly unstructured, and we don't know necessarily where all the bits and pieces are. We might know them within a foot, but for a robotic system, that could be quite challenging. And it's actually hard to predict sometimes the final cost because of the nature of the challenges. So if we can address all that and come up with a piece of technology that does that, that'd be fantastic. Move to the next slide, please. Okay. Normally we just give you the challenge and walk away and say, come up with some great answers. But today I've put a little twist on it. I actually want you to come from the challenge via a different approach. I want to try and stimulate your creative juices in such a way that you can actually look at a vision, and from the vision then understand what technology we might need. So if we click to the next slide, and the types of visions you might come across with is, how can we enhance the operator in a cell? How can we, again, enhance the type of remote equipment that we can deploy to solve the problem? Intelligent hand tools that are more than just a grinder or a shear. And clever search and characterization type technologies in order to understand the cell and the environments. There's lots more. These are just a couple of the types of things that I would expect you guys to start thinking up and then understanding how we would actually develop this vision. So that's just a few ideas, and the next couple of slides are aimed to give you a little bit of a feel. So if you click to the next one, please. And if anyone's into sci-fi, they'll probably recognise it instantly, but can we have a protective suit in some way to give to the operator to operate in the environment? And may get inspiration from
Paul, do we still have you?
Yeah, we do.
Sorry, we wasn't able to hear you then.
Oh, do you want to say that again?
Please, if you could, yes, thank you.
Okay. This is a technology that most people might recognise in our films, but can we make this type of technology a realisation to protect our operatives in harsh environments? Maybe some sort of adaptive suit armour. Next slide, please. Maybe some clever hand tools. Can we actually maybe have handheld lasers in some shape or form? Lasers are certainly a magic knife in this world, but you might need to be able to control that magic knife in such a way to make it available to us. Next slide, please. We're going to gather an awful lot of data from characterization. And some of this data is in very hard form to understand. So can we do what's sometimes referred to as big data analysis and interpret the information in such a way that we can make informed decisions? And you'll see there some form of 3D heads-up display. And on the bottom picture is a scanning device which goes and characterizes facilities. Next one, please. This is a little bit less science fiction, but operator enhancements. Can we give them suits that will enable them to lift heavy weights or move quickly, or in some cases protect them from the environment they're operating in, and feed information to them in such a way that they can operate and understand what the task is. These are real devices, so it's not all magical sci-fi. Next slide, please. And then there's, at the moment, we send our individuals with a mic in, and there's very little information flow because the communications are very challenging. Can we actually give the operative better information when they need it? So can we give heads-up displays on where they need to go, where the dangers might be, how to take a particular piece of plant to bits? And there's a little bit of reality there with the Google glasses, and there's a famous movie character getting his information and talking and understanding his environment by talking with someone else outside. So can we have something like this possibly? Next one, please. And then there's the remote handling, and very famous character there. And this device will go into harsh environments, in this case maybe sci-fi harsh environments, but what would it look like? So there's one particular device. Next slide, please. And again, I do think that we can get inspiration from the imaginations of other writers, and can we have a device that we can understand our environment by, and again have simpler means of understanding the information and processing information to what we get. So you'll see there the famous tricorder. Wouldn't it be great if that could look through 3-foot thick walls, process the information, and give us the information in real time what we want? The saving on the site and other areas would be enormous. And again, there's someone actually interacting with an environment to actually get the data they want, so they can actually focus in on the challenge they've got. So moving, next slide, please. And this is the thought process is we've got very limited access, I think was mentioned earlier, but we want to be able to put a device into a cell through a small aperture, and we want that device to reconfigure itself or transform itself into another device to enable us to actually carry out decommissioning. So do we need something that can do that type of thing, and how would we control and develop it? Next slide, please. Characterization. Actually, this has got two elements. If we can make the nanobot world very cheap, we could actually send these devices in through pipes and through light ports and through windows in such a way that they could characterize the cell for us and then lay dormant until we need information. Or we could actually get them, if they get enough of them, to act like a swarm and collect up bits of radioactive material. And if they're, $1, is it, a go, we might be able to just then fall into the right bin and switch off. And we've then done some form of either characterization or cleanup. So there's maybe opportunities there using this type of technology. And it's there now, so can we exploit it? Next slide, please. So really what we really need to do is, I'm looking for you guys to think of a vision, and then we need to turn it into reality. So we need to think, well, what would it look like as a whole, and how would we use it? From that, I want you then to understand how you would break that vision down into the functional requirements, and then tell us how you're actually going to put your research work to deliver some of them functional requirements. I really don't want you just to say, well, I can give you a better gripper or a small part of the device, or I can send you a scanner. I want you to say to me, how am I actually going to use the data? In what form? What benefit would it give me? Through a vision. And I've got a next couple of slides is really trying to give you some guidance on what I'm thinking. So what we've got our futuristic vision, and then that breaks down into a number of sub-functions, functions and then sub-functions. If you slip to the next slide, it gives you some examples of that working out. So if we actually talk about future man entry into hazardous environments, what do we need to do? So we probably need to protect the operative from the cell. We might need to do pre-task planning so he knows what to do. We might need to give him some tools that integrate with his suit in some way, and he understands the behaviour of his suit. We might actually stop the cell interacting with the man, so we might send something in that fixes the system before he goes in. And we might actually give him some task support, so it might put heads-up displays on where to cut and how to take to bits. Next slide. That might break down again. So if we look at the protect the operative in there. So you might look at the different types of suits. You saw the science fiction suit I've just put up a few minutes ago, but that doesn't mean we can't have clever PVC materials that can self-clean themselves, self-repair, understand its condition during that cycle, as well as maybe some form of adaptive capability linked in with self-healing types of plastics. We've also got life support, so how do we maintain that operative in that environment? At the moment we have long umbilicals or filter systems, so what other things can we have? And there's a little list there, so we might be looking up heads-up displays, hazard detection. The suit might be able to detect the environment and understand the environment so the operative's in the safest position possible, and understand itself, the condition of the suit, and maybe even some form of recovery systems helps the operative come out if there's an accident or incident. Move on, please. And task support might be things like cut plans, dismantling plans, tool controls. And what I'm looking at is the academic fraternity to think of that vision, and you might be able to put submissions in against any of these key types of functionality. But I'm looking at you guys to tell us what that vision looks like and how that breaks down and how your research will actually push that vision forward. Moving on. Next slide, please. That's me completed my presentation. I'll now hand the chair across to Andrew Cooney, my colleague.
Hello, I'm Andrew Cooney. I'm part of Future Decommissioning, and I've got some overview of kind of academic links for Sellafield. I'm going to say a lot of kind of similar things to what Paul said, perhaps, but maybe in a different way. So obviously there's a lot of external technologies, or technological change that's going on. We need support in bringing those technologies in and adapting them to our environment. You know, Paul talked about RAS, Internet of Things, and virtual engineering is an important thing to us, I think, because we really can't mix with a hazard, so we need to do things outside, plan outside, etc. Can you move on to the next slide, please? Next slide, please. So the next slide is a 3D scan from a Sellafield created by Creator and React. What it shows.
Are you still there?
Yes, we're here. Andrew, can you hear me okay?
Yeah, can you move on to the next slide? Are you on an inventory and characterization slide?
Yeah, slide 31.
Oh, yeah. That's it, yeah. So what was that showing is a 3D scan inside a cell. Yeah. So what we're looking for in terms of characterization is imagining operators having handheld monitors that can accurately locate and identify and characterize the radioactivity within the cell, and then provide that information to people able to make decisions, support their safety in the cell, and help them optimizing cut plans and things like that. So somehow we need to create these rich environments with information from the history of the plant as well as today's information. So that's kind of, we've got bits of that technology, but that all needs stitching together. Can I move on to the next slide? The next slide's about protecting people. So our suits probably date back quite a long way, and that's why I showed a picture of the Apollo 7 suit. But more recently, in warfare and in a kind of exoskeleton development, there's been a lot of developments. What Paul maybe didn't say is that there's up to 7 layers of protection and clothing in the suits. The boots are full of sweat, and people are at risk of heat stress. They're cumbersome and difficult to work in. There's complex dressing and undressing procedures, so there's a real big area for innovation there. Again, people are starting to work on exoskeletons, which are perhaps coming up from the other side from Paul's, who's the man from Iron Man, the kind of the iterative approach as well. We've got opportunities. So, can we develop a one-layer suit that can monitor itself, can repair itself, can clean and filter the air, and is tough? What materials could we use? Okay, next slide, please. So, I mentioned decontamination earlier on. One of our problems is we've got effluent infrastructure at Sellafield, which is based on the effluents arising from normal operations. As we go into decontaminate plant, we need to use different reagents to decontaminate the plant, and our existing infrastructure is not necessarily capable of coping with that. So we've got to look at alternative ways of decontamination, which may be dry as suggested, or it may be wet, and we may have to treat or pre-treat the effluent locally, and we need more options to do that. So how can we develop intelligent chemicals or intelligent application methods that just focus and minimize the amount of reagent used? And how can we then detect that we've been successful? Next slide, please. So the picture on the left is one of our highly active storage tanks. It's 150 meters cubed. It contains cruds and contaminants. The doses preclude human entry. And so we've really got to address how we're going to dismantle those cells. And it's not a long time off. It's maybe 5 to 10 years off to dismantle those tanks. May need to decontaminate them. May have to use rather advanced remote machines to take them apart. Got limited access, high doses. Can't really afford to lose equipment in them. What a challenge. Okay, next slide, please. So, the next slide is, people often say, can we use agricultural technology? And it's maybe not appropriate, I don't know, I find that a bit of a challenge. And traditionally, I put the Rolls-Royce there because we've tended to use bespoke technology. But really, I think the trick for us is going to be that middle line in technology. And how we turn out what are bespoke operations where you go in and characterize, you go in and dismantle, you go in and collect the waste, and you then have a number of steps in the process into a seamless process. So really, in order to reduce the amount of time and the associated cost, we've got to look at how we turn what we do into a production line. Again, not sure how you do that. Okay, next slide, please. Next slide's about care and maintenance. You could also call it how you take the plants dark and dry and inexpensive, because whilst we've got a lot of facilities at Sellafield, we have to put some plants in a low-cost, safe environment while we proceed with to decommission the other plants, and the less cost associated with those plants in care and maintenance, the more we can focus on decommissioning. I put Frozone there because wouldn't it be nice to just be able to freeze the plants and prevent them decaying? Because at the moment we've got to spend quite a bit of money dismantling plants. So how can we minimise the amount of maintenance we need to do on those plants and minimise the amount of decay on those plants? How do we monitor them using simple sensors and simple arrays and prove them to be safe? Okay, next slide, please. So I hadn't quite realised you'd had a land quality one before. I was actually going to draw your attention to the pictures on the right to some extent, because a lot of what we assume at the moment is a kind of human-scale paradigm for the way we're going to decommission. But the questions are, what if you adopted a kind of large-scale paradigm? How would you move big things around? How do you monitor big things? And how do you dispose of big things? And equally then, if you go to the small scale, mentioned swarming robots, and that's going to be a lot more efficient in some ways. And how do you decide what's the best scale to do decommissioning on? Next slide, please. So earlier in the year, we were considering tech transfer opportunities from other sectors, and I think academia can be a big help in this. In space, they have to tolerate high radiation. They have to manage with people in hazardous environments. And quite interesting is the way they have to communicate with space rovers, in which they can have limited interaction with space rovers. Again, they have to deal with very low energy environments, so it's a problem for us. Well, you've got sensors in plants for long periods. Again, tech transfer from the military is another interesting area for us, armour and protection. How they achieve command and control, maybe how we might use shaped explosives in decommissioning, and then again, they've got big challenges in seeing inside buildings to understand what the risk of terrorist activities are. And then there's other sectors as well, such as railways and oil and gas, where we can learn from, I think. Okay? I think that was my last slide.
Thank you, Andrew, and thank you everyone else for contributions to the presentation. So we've got about 20 minutes now available for any questions that you currently want answering. As Rick said before, there is a chat option if you're online, but if you've dialed in by your phone, you can press the star key and then number 4, and that will unmute you if you have any questions you want to ask. I'll hand you over to Lorraine McDermott, who will go through those questions. We currently haven't had any through at the moment, so we'll just give it a couple of minutes for you to type those in if you have any.
Good afternoon, everybody. I'd just like to say thank you very much to all of our presenters this afternoon. A very interesting presentation that's hopefully provided you some background on the scale and challenges faced by decommissioning at nuclear sites, and highlighted those research needs and opportunities for innovation, even if that innovation is applying technologies from other industries to nuclear and overcoming those implications. It can take a few minutes for questions to come through on the system. So we'll just hold the line and allow everybody time to respond. I'd also like to thank the people who have dialed in and attended. We can see that there's a few people who've been to quite a few of the webinars. I hope that you found them a benefit in responding to the NDA call, and they've been of some value to you. On the NNL website, with the information for the NDA Bursary call, there is also Mark Bankhead's email address. If you have any feedback for us on the webinars, please do let us know, good and bad, and areas where you would like to see improvements. Always happy to receive feedback. We've just received a question from Oliver Payson. Thank you very much. The question is, cost is important. Many of these technologies don't exist yet, so how can we judge what is good value to you? We pose that to the gentleman at Sellafield Limited.
Yeah, I can answer that one. I think, and I'll see if I can get the numbers right, and my NDA colleagues can to refer back to that. I think in round terms, to decommission Sellafield sites, it probably cost in the order of around 70 billion. I think to decommissioning all the liabilities across the UK is around 120 billion. We're talking of a time scale of very approximately probably between 50 and 100 years. So right at the moment, my understanding is with that time scale and that amount of opportunity to go for, it's up to your imagination. And if we can start with the early development of these type of technologies and the correct way and supportive way that hopefully we can give as you move through the development, cost will be a factor, but we'd like to think that by giving that starting thought now, that even though some of these technologies aren't available, I would like to think some of these, certainly from what I've seen, some of them are knocking on the door now, and some may take 10 to 15 years. That still gives us probably 30 years of using that type of technology. So yes, cost is important, but my thoughts is cost will probably start coming into it when we start looking at using it. And this is probably where the technology moves from an academic type challenge into the deployment type challenge. But to keep an eye on it, because if it costs us £1 billion to do something, we will not be interested. But if the development cycle, if you just look at it, the size of them numbers, if we make 1 or 2% saving, we're talking of very large numbers. And it will actually fuel a reasonably strong development program just on them type of numbers. Hopefully that answers your question.
And I think as well, just to add a little bit more to that as well, as Paul said, the numbers are already really quite large, especially when you consider the next century or so of time that we're carrying out the mission over. But not only that, is that a lot of these technologies may result in reduced waste volumes, because if we can do more effective decontamination, if we can find better ways to target specifically more highly contaminated areas, and maybe extract those small amounts of material and thereby reduce the actual amount of waste volume that's going to be classified as, well, currently intermediate level waste, but perhaps in the future just higher activity wastes, then we can vastly reduce the costs associated with disposing of that waste as well. So it's not only going to affect, for example, the cost of Sellafield cleanup, but it will also affect the cost of the geological disposal facility that we'll have to build at some point in the future.
There's probably one other bit which we're not looking at, is that I'd expect you guys to actually look further afield than just Sellafield. There's a massive clean-up business internationally.
Thank you very much, Paul and Rick. If people have any more questions, please do either unmute your microphone or type it in on the text box. So the response there was cost is important, and that needs to be kept in alignment with the cost of decommissioning that are faced by the sites, and also looking at international kind of experience and things that are happening abroad. And Rick mentioned there about the implications for long-term disposal and reduction of waste volumes and things like that. Would you also say, gentlemen, that there is a link as well to making something more automated potentially has a saving in terms of the people, so there's kind of less stress on the individual who's then not suiting up accordingly, and also the risk and potential kind of drops as well as systems become automated?
Answer that one. Absolutely. We're continuing to strive to make the environment safer and easier to operate within. So I think the answer is yeah. Quite a simple one.
Yeah.
And that's balanced off with the technology available. This is why we're showing, from our perspective, looking at how the operative interacts with the environment and how we can put someone else in there to actually carry out that task.
Yeah, I think with all these things, you also shouldn't forget about the massive amount of data that will be generated and how we're going to process and deal with all that data and how we extract the knowledge and the insights we need from this data and our historic data will be quite a challenge to us in a secure environment.
Does that answer the question?
Yes, thank you very much for responding. Oliver has also responded and said that you've answered his question, and thanks. While we've had a few minutes to receive those questions, do please type in immediately now if you have anything further you would like to ask the presenters that we've had today. So I'll finally kind of wrap up this webinar on decommissioning for the NDA Bursary call. Thank you again for all of those who have attended and all of the presenters, particularly Christina, who stepped in as we had a presenter that had technical issues and was unable to dial in. Really appreciate that. I would just like to remind all of the people who are currently writing their proposals to respond to the NDA call that the closing date is on the 20th of October 2015. Thank you very much, and we're now going to close the webinar.